Biochemical processes such as photosynthesis and respiration occur in a series of small steps, rather than in a single chemical reaction. For example, cellular respiration is often represented by the formula oxygen plus glucose reacts to form carbon dioxide, water, and 36 ATP. And this represents respiration as a single step, when in fact, cellular respiration occurs in a series of steps which are regulated by enzymes. So, for example, there are several steps in cellular respiration, including glycolysis, the Krebs cycle, and the electron transport chain, and each of these is regulated by enzymes. Now, why this may look like a slightly more complicated process, you can actually look and see the products and reactants of cellular respiration. For example, glucose, a very important reactant, oxygen, the other important reactant, and of course the products are going to be carbon dioxide, water, and ATP. These series of regulated steps are called biochemical pathways or metabolic pathways. And there's a simpler way to look at it. So if you were to just look at a simplified version of any particular metabolic pathway, what you'll find is that you can take an initial reactant and it requires an enzyme to change that into a product. Let's just say product A in this particular case. Product A then becomes the reactant for another reaction catalyzed by another enzyme, which forms product B. And then of course product B becomes the reactant, which is reacted by another enzyme to form a product C, which is the final product in this reaction. So the product of one step of a metabolic pathway becomes a reactant for the next step, and this ensures that products from a previous step are continually being removed by being the reactant for the next step. There are certain reasons as to why biochemical reactions occur in a series of steps rather than in a single reaction. Firstly, it enables cells to maintain control over the overall metabolic process by controlling each step in the biochemical pathway. In this way, cells precisely control the rates of the biochemical reactions that are vital to the survival of the organism. Secondly, biochemical reactions are reversible under certain conditions. It is important that products are removed from the cells so that they do not build up and slow down or reverse biochemical reactions. Because the products of one reaction participate in the next reaction, each stage of the metabolic pathway are more likely to proceed. Finally, heat is generated as a product of metabolic processes. The individual steps in the metabolic pathway ensure that only a small amount of heat is released at a time, ensuring that they do not burn up and overheat the cell. In addition, this heat can then be used to fuel other biochemical reactions.